Okay, so guys, let's look at this question. Find the equation of the normal to the curve y is equal to x squared minus 3x minus 4 at the point 2 comma negative 6. So we have been given this function, which is y is equal to x squared minus 3x minus 4. Okay, now we are told to find the equation of the normal. We are told to find the equation of the normal. So step number one, what we are going to do is we are going to differentiate this function. We are going to find dy dx of this function. Okay, so we are going to say dy over dx is equal to, now we know that when differentiating, I said you first multiply the power by the coefficient. So in this case, the coefficient is 1. So we multiply 2 times 1, get 2x. Then you subtract 1 from the power. Okay, so this the power is 2. So we're going to subtract 1. 2 minus 1. Then in this case, the power is 1. So when you multiply the power by the coefficient, which is negative 3, you're going to have 1 times negative 3, you're going to get negative 3x. Now this power is 1, so we're going to subtract a 1. Then minus, remember, differentiating a constant number is 0. Okay? Then we can move on and say dy over dx is equal to 2x. 2 minus 1, you get 1, minus 3x. 1 minus 1, you get a 0. Okay? So we're going to have dy over dx is equal to 2x minus 3. We know x to the power 0, the answer is 1. X power 0, the answer is 1. So we're going to have 1. And finally, we're going to have 2x minus 3 times 1, get a 3. So this is our dy dx. This is our dy dx. So now, having known what our dy dx is, so this is our dy over dx. Next thing, we are going to find the gradient of the tangent. Okay? So for us to find the gradient of the tangent, we are going to use this gradient function. Okay, to find the gradient of the tangent. Where there is x, we are going to substitute with what? Because we have been given the point to be what? 2 comma negative 6. Okay, so this is x, this is what? Y. So where there is x, we are going to put what? 2. We are going to substitute what? 2 to find the gradient of the tangent. So we are going to say gradient of the tangent is equal to 2. Where there is x, you put what? 2. So we put 2 minus 6. Okay? So we can move on and say gradient of the tangent is equal to 2 times 2, you get 4 minus 6. Okay? So gradient of the tangent is equal to 4 minus 6. You get what? You get negative 2. So negative 2 is the gradient of the tangent. Negative 2 is the gradient of the tangent. So now, we're going to find now the gradient of the normal. Since we are told to say, find the equation of the normal, we need to find the gradient of the normal. We are not supposed to use the gradient of the tangent, no. We use the gradient of the normal. So we need to find the gradient of the normal. Okay. So now in this case, how do you find the gradient of the normal? So gradient of the normal, you say, gradient of the normal, we know that gradient of the normal multiplied by gradient of the tangent, the answer is equal to negative 1. Okay, gradient of the normal multiplied by gradient of the tangent, the answer is equal to negative what? 1. So in this case, what we are going to do is we are going to substitute and say gradient of the normal, this is what we want. What is the gradient of the tangent? It's negative what? Negative 2. So times negative 2. The answer is equal to what? Negative 1. Okay, so gradient of the normal times negative 2, you get negative 2 gradient of the normal is equal to negative 1. Then for us to mean with gradient of the normal, we're going to divide both sides by negative 2. Negative 2 this side. So these are going to go. Then we're going to have the gradient of the normal is finally equal to what? 1 over 2. So this is the gradient of the normal. Okay, so we have the point which is 2 comma negative 6. We also have the gradient of the normal to be 1 over 2. So we are going to consider this as our x1, then this one as our y1, plus we have the gradient of the normal, which is 1 over 2. Okay, so now here what we're going to do is we're going to find out the equation of the normal using this equation. Y minus y1 is equal to gradient of the normal, in this case open brackets. Okay, then we're going to have x minus x1. Okay, so it's maintain y should be part of the equation minus what is y1. Y1 is negative 6. Okay, so we're going to multiply this negative and this negative. So negative times negative 1 becomes positive 6. Okay, because y1 has got a negative. So this negative 6, when you substitute negative 6 where there is y1, you're going to have negative times negative, it's what? Positive. So it's equal to, what is our y1? So what is our gradient? Gradient of the normal, it's what? 1 over 2 open brackets x minus, what is our x1? X1 is positive 2. Okay, so in this case we can simplify this one. First we can remove the brackets and say, or if you want you can just cross multiply direct. Okay, to make your work easier, you just say over 1, then you cross multiply. Okay, meaning we are going to multiply this 2 times y, you get 2y, plus 2 times 6, you get what? 12. Okay, is equal to 1 times 1 is just 1. 1 times x, get x. 1 times negative 2, you get negative 2. Okay, so at this point we are going to group the like terms, because we know our equation should be standard. Our equation should be like y is equal to mx plus c. This is the way our equation should be like. So we need to make y the subject of the formula. So we are going to begin with 2y this side is equal to x minus 2. Now this is positive 12. When you transpose this positive 12 on the other side, you're going to have negative 12. Okay, so we're going to maintain 2y is equal to x negative 2 minus 12. The answer is negative 14. Then for us to remain with y, we're going to divide by 2. Divide by 2. So these are going to go, y is equal to x over 2 minus 14 over 2. So this is the equation of the normal. Okay, this is the equation of the normal.